Okay, in this video we'll look at solving and sketching some linear and quadratic simultaneous equations. And the first example we'll take a look at is use substitution to solve the following system. Y equals minus x minus 11 and the quadratic y equals 2x squared minus 7x minus 3. And I'll just take a look at the math pad and note the equations. So the linear equation, we had y equals minus x minus 11, and the quadratic y equals x squared, that was y equals 2x squared minus 7x minus 3. Okay, so we start by setting the quadratic equal the linear because the value of y is common to both equations. So I'll say 2x squared minus 7x minus 3 equals minus x minus 11. I'll bring everything to the left and set it to 0. So we have minus 7x plus 1x minus 3 plus 11. And bring the terms together, giving me 2x squared minus 6x plus 8 equals 0. Now I can solve this for x, but first I'll divide across by 2. X squared minus 3x plus 4 equals 0. So this will give me factors x minus 4 and x plus 1, giving two possible solutions for x. So x is positive 4 or x is negative 1. So we just have to use each of these x values to find the corresponding y value. So y equals, easiest to sub it into the line, y equals negative 4 plus, that's negative 4, negative 11 equals negative 15. So the first coordinate, the first point has coordinates 4, negative 15. And the second point we'll sub in the minus 1. Gives us negative 10. So the second coordinate, the second point that lies on both of these equations is negative 1, negative 10. Okay, so that's example 1, and we'll just go back and take a look at another example. So example 2 is solve and sketch the following 2-degree system. This time the linear is y equals 7x minus 8, while the quadratic is y equals x squared plus 3x minus 4. And we'll just skip across to the notepad and take a look at each of those equations. So the line is y equals 7x minus 8, and the quadratic y equals x squared plus 3x minus 4. Like in example 1, we'll set them equal. X squared plus 3x minus 4 equals 7x minus 8. Move everything to the left. X squared, 3x minus 4x, sorry, that's 3x minus 7x is negative 4x. And then we have negative 4, positive 8 is plus 4. Set that to 0. So if we take a look at the factors in this case, we will have a one repeated factor, which is x minus 2, and again x minus 2 equals 0. So that will give us just one value of x. X is positive 2. And if we take a look at the x is positive 2, sub it into maybe the line. We could sub it into either line or quadratic because we know it is on common to both. We will get a value for y. 2 times 7 is 14, minus 8 is 6. Okay, so the point that is on the curve is 2, 6. Now it's just one single point, which indicates that it is actually a tangent line, and it's a tangent line on the quadratic when x equals 2. So let's just have a quick look at sketching the system we've just solved. We'll maybe have a look at the quadratic first. The quadratic I'll just draw the y-axis here. We'll go back up here and draw the y-axis down there, and we look at the x-axis across like that, and y. And we want to sketch this quadratic. So if we quickly look at this quadratic, we could factor it for x plus 3, x plus 4, and x minus 1, which will give us two solutions for that quadratic of minus 4 and positive 1. And we can see the y-intercept is minus 4, so we'll just quickly draw that quadratic. We'll just call this positive 1. So it's going to go something like this. So that's the y-intercept is negative 4, and the line happens when x equals 2. So we're going to just pop that line running through a tangent line, just touching the quadratic in one place only. So that gives you a reasonable representation of it. I'll mark that point 2, 6. It is a sketch only, it's not perfectly accurate, but good enough for our purposes. We've all the key points marked in. Okay, so let's take a look at our final example. And the third and final example is to find the points of intersection between the following circle and line. And the circle is x squared plus y squared equals 13, and the line is y equals x plus 1. Okay, so we'll take a look at this example. Example 3, we've got a circle given by x squared plus y squared equals 13, and we have a line y equals x plus 1. Okay, so what we're going to do is we'll use substitution. We'll sub the value of y from the line into the circle, and that will give us an equation in x. So we will have x squared equal, x squared plus, now the y squared we will sub in x plus 1 squared equals 13. And I'm going to expand my x plus 1 squared. So we have x squared plus x squared plus 2x plus 1 equals 13. Bring everything to the left. I've got 2x squared plus 2x. Now I have 1 minus 13, which is minus 12, equals 0. Now in solving this I can divide out by 2 x squared plus x minus 12 equals 0. So I can factor this one. I need two values. When I multiply them, give me minus 12, and when I add them, give me positive 1. So that would be positive 4 and x and negative 3. Giving me two values of x. X could be negative 4 or x equals positive 3. Now again, I need to find the coordinates of the point of each of these points. So I'll take my value of x and for ease just sub it into the original y, the line we had y equals x plus 1. So minus 4 plus 1 is negative 3. So the first point has coordinates negative 4, negative 3, and the second point y equals 3 plus 1 is 4. So the second point will have coordinates 3, 4. And that's the end of this short video. So thank you for watching and listening.